Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to this channel Chandan Physics. In this video, we are going to discuss all about Nicol Prism. Let's begin. What is Nicol Prism? Its construction, principle, working and uses of Nicol Prism are discussed in this video lecture. Nicol Prism is an optical device that is used for producing and analyzing plane polarized light, and it was invented by the scientist William Nicol in the year of 1828, and it is designed from a crystal of calcite. The construction of that of Nicol Prism by using calcite crystal. Under what principle that Nicol Prism acted? Principle: when a beam of ordinary light means unpolarized light, is passed through a calcite crystal, then the incident beam splits up into two refracted rays, such as one is ordinary ray, which is polarized, having its vibration perpendicular to the principal section, and another one extraordinary ray, having its vibration parallel to the principal section. This one is the phenomenon of double refraction, as we have previously discussed. So the Nicol Prism based upon the principle of double refraction. In case of double refraction, when an unpolarized electromagnetic wave incident on that of calcite crystal, then two refracted rays are there, one is O ray and another one is E ray. O ray, that is ordinary ray, which obey the laws of refraction, another one is extraordinary ray, which doesn't obey the law of refraction, and O ray, which is polarized, having its vibration perpendicular to that of plane of the paper, and the E ray, that is also plane polarized electromagnetic wave, that vibration parallel to that of principal section or plane of that paper. In the Nicol Prism, ordinary ray is cut off by total internal reflection. Here another optical phenomenon occurred, that one is total internal reflection for that of ordinary ray, and that ordinary ray is cut off by that of optical phenomenon, so that we only collect that extraordinary ray that is transmitted through that of prism. Okay, this is the principle for that of Nicol Prism. Next, come to the construction part. How Nicol Prism is constructed by using calcite crystal. We use calcite rhombohedron type of calcite crystal, where the length is 3 times its breadth. Let us choose rhombohedron calcite crystal. The rhombohedron calcite crystal. Rhombohedron calcite crystal, where that the length is 3 times of its breadth. And that angle is 71 degree, and this angle as 109 degree. 109 degree. We named it as A, B, C, D, E, F, let me cut that rhombohedron calcite crystal in such a way that angle 71 degree is reduced to 68 degree. First we have to show what will be the principal section of that type of crystal. The principal section we show by taking that point, this point, that point to this point. So the section under this that red shaded region is our principal section. That red shaded region the principal section of the crystal. Now that two end faces of the crystal are cut in such a manner that original principal section A, B, C, D. Here is the original principal section. I draw here. So original principal section named as A, B, C, D. That original principal section is changed to A, B dash, C, D dash. It is changed to this is the original one. D point is there, B point is there, A, B, C, D, that is the original one. Here it is changed to B dash and D dash. As this angle here it will be 71 degree. So it is reduced to this angle as 68 degree. Then ultimately this angle changed to 112 degree. Okay, that the principal section is cut like this way. That's why that 71 degree angle reduced to 68 degree. Now that a crystal is cut into two portions. We cut that crystal into two portions like this way. Now these two crystals are separated just like two prisms, and these two prisms are now combined by using a transparent liquid. That transparent liquid we called Canada balsam. Canada balsam. Transparent liquid is used for joining. It's called Canada balsam. Canada balsam. That Canada balsam having the refractive index within the range of the refractive index of E ray and O ray for that of calcite crystal. Let's come to our objection. When an unpolarized electromagnetic wave is incident, this is unpolarized electromagnetic wave is incident on that of calcite crystal, or we call it as now Nicol Prism. Then it is split up into two ray, one is E ray, another one is O ray. It is split up into two ray, one is E ray, another one is O ray. In that of E ray, these are parallel to that of plane of that of paper. For O ray, these are perpendicular to that of plane of paper. Here at that of surface, for that of for that of O ray, the refractive index of O ray is greater than that of refractive index of Canada balsam. So here the phenomenon of total internal reflection takes place. That's why, since that angle of incidence is greater than that of critical angle, then the phenomenon of total internal reflection takes place, and that O ray is now totally reflected back to that of surface AB. And here that surface end is lamp black. On that surface we use lamp black. black is used, so that O ray is absorbed in that of surface. And here the refractive index of that E ray is lower than that of refractive index of Canada balsam. So that E ray is passes through that of Canada balsam and it is slightly refracted, and finally at the output we achieve E ray, which is plane polarized. So by using Nicol prism, from that of unpolarized light we obtain polarized light, or we can say for that of unpolarized electromagnetic wave we obtain polarized electromagnetic wave. This is due to the phenomenon of double refraction. Come to the working process. As I say, the main factor here is the refractive index. As I choose here Canada balsam. Here the refractive index of calcite for the E ray, that is refractive index for E ray is equal to 1.49. Then for the O ray, the refractive index for O ray mu of O, that is 1.66, and for Canada balsam, the transparent liquid which is used to cementing these two prisms, the refractive index of Canada balsam mu of B is equal to 1.55. That is the refractive index of Canada balsam under that of what? The refractive index for O ray and the refractive index of E ray. So on that basis of refractive index we can say E ray is rarer and O ray is denser as comparison to that of Canada balsam. Come to that figure. Since O ray is denser to that of Canada balsam, so when a ray travels from denser to rarer medium and the angle of incidence is greater than that of critical angle, then the phenomenon of total internal reflection holds good. Look at that of expression, we can easily calculate what be the angle of what is the critical angle. the critical angle for Canada balsam, that is sine of theta c is equal to refractive index for that of Canada balsam to that of refractive index for ORE, which is equal to 1.55 divided by 1.66. So theta c is equal to sine inverse that ratio as 0.933, which is nearly equal to that angle is 69 degree. So when that angle of incident for that of O ray is greater than 69 degree, then it is show the phenomenon of total internal reflection. As the angle of incidence for O ray is greater than that of critical angle, then it is show the total reflection phenomenon, and O ray is totally reflected back and absorbed by the surface of the Nicol prism made of lamp black. Next, for that of E ray, it is show the rarer one as comparison to that of Canada balsam. So that ray is polarized and passes through that of Nicol prism, and finally we obtain the plane polarized light in the form of E ray. Again for E ray, it is rarer as compared to that Canada balsam, so it passes through this and we obtain plane polarized light. Okay, this is the working that we observe in case of Nicol prism. In that of Nicol prism, the phenomenon of double refraction as well as for that of O ray total internal reflection takes place. Next, uses of that Nicol prism. That Nicol prism is used both polarizer and analyzer situation. What is polarizer? As we show in that of section, we obtain polarized light by using Nicol prism. That is a Nicol prism when an unpolarized electromagnetic wave is incident, so here is the O ray and there will be the E ray, that is E ray, and that E ray again another Nicol prism is used parallel to that of Nicol prism N1. So it is obvious that the E ray passes through that Nicol prism and finally we obtain polarized E ray. So this is the polarizer, that one is the analyzer. By using that polarizer we obtain polarized light. By using that analyzer we detect either that the light is polarized or not. This is the condition for parallel Nicols. These two Nicol prisms are parallel with each other. Another situation, if it is crossed, this is a Nicol prism, N1, unpolarized electromagnetic wave reflected back, E ray, and here we use that analyzer. That analyzer N2 now crossed. So the intensity of that polarized light now decreased and absorbed by that of Nicol prism, since it is crossed to that of Nicol prism N1. So here it is clear that Nicol prism is used as analyzer as well as polarizer. This is the uses of Nicol prism. So here with the help of this video lecture we understand the concept of Nicol prism. What is Nicol prism? Under what principle that Nicol prism acted, construction, working, uses. So with this useful and informative notes, let me wind up the session. Thank you.